Hey, welcome back, chemistry class. Today we're going to be discussing properties of matter and what determines a property of matter. Let's have a quick review session of what matter is. Matter is anything that has mass and takes up space. Remember when we talked about our discussion of what matter was and the categories of matters, and we understand that matters are broken down into the pure substances and mixtures. But we can say in a better way that the most pure form of matter is going to be elements. They have the same atom all the way throughout. But when those atoms bond ionically, covalently, or metallically, they form a compound. That means it's still going to be a specific group or combination of atoms bonded together the same way all the way throughout, and that's a compound. But when compounds start mixing together, and they mix so evenly that you can't tell them apart, but they're still not bonded, that's a homogeneous mixture. When compounds or homogeneous mixtures mix together, and you can tell the difference because the particle sizes are big enough to tell the difference, that's called a heterogeneous mixture, and we have colloids and suspensions. Now, we remember that from class, and I hope we do not forget that, and this will help lead us to our conversation on describing those matters and those arrangement of atoms. But before we can do that, we have to understand when we're talking about matter, we're going to be specific about a specific type of matter. It's properties of matter. It's not properties of all matter or properties of this group of matters that have similar things about them. No, it's a properties of a specific kind of material or specific type of compound. In order to understand that, then you have to get to the term of chemical composition. It's a properties of a specific chemical formula, which then you have enough of that compound, you can have the matter, right? And so a chemical composition, and when we are talking about matter, we are talking about really one thing, and that's a specific chemical composition. That's when things that a specific compound have. We're talking about which atoms are involved, and that which atoms are involved. 2, how many are those atoms? How many? And then the last one, 3, the arrangement. So those 3 things determine its chemical composition. Which atoms, how many, and the arrangement of those atoms. So we'll spend most of our time talking about which atoms and how many, and a little bit how they're arranged when we get into the VSEPR theory, or when we talk about how we start talking about the molecular formulas of things and arranging those. But we're not going to get into the more complicated part when you have an isomer, which is when you have 2 atoms, 2 chemical formulas that are exactly alike and they are arranged differently. That's called an isomer. So for instance, like the most common one I guess would be carbon, right? And you have the graphite. You have an isomer is graphite, and then you have diamonds, and then you have other things that the graphite that you put on things to make things super slick, like when you're trying to get a key into something. Those are all isomers of carbon. Now, the chemical composition, I have 2 of these over here. Do these have the same atoms involved for these 2 right here? Yes. Why? In fact, they do. They have a hydrogen and an oxygen. So, which atoms are involved? Hydrogen and oxygen. That's how they're similar, right? But that doesn't mean they're the same types of matter. The reason why they're not is because of the how many part. So this has 2 hydrogens, this has 2 hydrogens, okay, 2 oxygens, but 1 oxygen. So that alone means this is going to be a different type of matter because of the chemical composition. Not to say that they're obviously going to be arranged differently now because they have different atoms, or their atoms have more or less of a specific atom, so they have to be arranged differently. Take this. This is carbon monoxide and carbon dioxide. This we have in our body. This we also have in our body. Oh, for that matter, we have water and H2O2. That's used specifically in our cells to break down material. It's peroxide, as you talked about in class before. But this carbon monoxide, in enough quantities, is dangerous to us. But in specific places, it's really good. It's in some ways, it's a neurotransmitter in the brain. Carbon dioxide is important for as we remember, it's important for the production of sugars. So that's important too. And when we go to talk about photosynthesis, then we talk about the production of sugars, which is the cellular respiration aspect of it. So these all have their places, but they're all different because They have different types of atoms and different combinations of those atoms. And because of that, because of those arrangements and because of those atoms involved, they're going to have different properties. And we can track those properties and then use those properties to identify them. So if I had a glass of hydrogen peroxide, and it's got H2O2, and then I had a glass of H2O. Would you think it's important to know the difference between the two of them if they weren't properly labeled? Yes, you would, and you would know this because of their chemical or physical properties. So let's get into what those chemical and physical properties really mean. So when we are talking about a chemical or physical property, we are still both talking about the properties made up by that chemical. It all has to do with the atomic level. Don't get confused and think that a physical property isn't due to the chemical composition. Both physical and chemical properties rely on the chemical composition of a compound. They both are directly due to the chemical composition. Okay, so I hope that don't get that mixed up. Just because something is a chemical property, don't think that has more or less to do with its properties of chemical composition than physical. But what the difference between a chemical and a physical property are, and if you are taking notes, I would advise you write this stuff down in your own set of notes, so that way you can have this for later. Not only we have this in class, but you should also write this down again. There's no harm in doing it. A physical property is a property that can be observed without changing the composition, the chemical composition. While chemical property is the opposite. It's the opposite. It can only be observed by changing the chemical property, the chemical composition. That's how we know it's a chemical property. So another way to look at this is a chemical property is really talking about how one compound interacts with another compound. That's basically what it's saying. I hope that's not confusing. That's all it's really saying. That the chemical property, the list of chemical properties is a lot shorter than the list of physical properties. So all a chemical property is really saying is if it will react with something else, and how it will react. Okay? So let's now, we're going to hit chemical properties later, but I can spend more time on that in a second. But now let's start discussing physical properties. As you can see, physical properties has two subcategories to it, and it's intensive and extensive properties. And I'm going to start writing down a list of some intensive properties and a list of extensive properties, and see if we can't on our own determine what the difference between the intensive and extensive. So let's talk about density is an intensive property. Viscosity is an intensive property. Viscosity is just saying how something, how flowing it is. If something is high viscosity, it's like syrup. It takes a long time to get somewhere. It flows slowly. And low viscosity is like water. It flows really fast. So that's viscosity. Melting point. This will be on an exam, so please know this. Melting point, boiling point, freezing point, all those things. Luster. Those are all permeability. That's another one. That's another intensive property. Now, we can say solubility. Well, we can say solubility is maybe an extensive property. Now let's get into some extensive properties. How tall it is, the mass, the volume. So when tall, I mean length. So anything to do with the length of something. I'm drawing a blank on some other ones, but those are Those are some extensive properties. So can we kind of, looking from here, kind of see what intensive and extensive is? And you can pause it now and try to come up with the answer on your own, but I'll just get back into it. So an extensive property is a property that is dependent on the amount of that matter present. So if I have a gallon of water and a cup of water, it will have different volume, it will have different mass, it will have a lot of different things on them. But if I have a gallon of water and a cup of water, every molecule of that water is going to have the same melting point at 0 degrees. Every one of them. They're going to have the same freezing point too. You have different boiling points. They will, they'll have different boiling points. They will all have a boiling point of 100 degrees, whether it's a gallon or whether it's a cup. If I had a lake of water, pure H2O, it will still take 100 degrees to boil that water. Now, it'll take longer to boil only because it will take longer to heat up all of that water to 100 degrees. But still, it still will require only 100 degrees. So extensive changes by the amount, while intensive is completely independent of the amount. Take density, for instance. In class, I asked if you thought density was an intensive or extensive property, and you said, a lot of you, your first thought was, well, it's extensive because it has mass and volume, so it's extensive. Well, the mass and volume are a ratio. So every time my mass went up, my volume went up at the exact same amount, regardless, every single time. And so that left, whether you have an ocean or you have a cup or a teaspoon or a 3-liter bag, the density of pure water is still going to be 1.0 grams for every 1 milliliter. It's the same no matter what. So that's what that's the difference between intensive and extensive. And all these different things, it doesn't matter how much you have. The luster of it doesn't matter if you have a whole warehouse full of shiny aluminum. It's all going to be shiny. Or you only have a couple handfuls of aluminum. Now, let's use aluminum as a jumping point into the chemical properties. So say I have that mass of that whole bunch of aluminum. I have a warehouse of aluminum. Over time, the outside of that aluminum, the very outside of that aluminum is going to turn into a different color. It's going to lose its luster. Is it because that somehow time changes the chemical composition of aluminum to make the aluminum, new aluminum versus old aluminum to be brighter or not? No, it's because if I have a chunk of aluminum, the outside of that aluminum is going to be inundated with a bunch of oxygen. So I have my aluminum, and then I have my oxygen, and then over time it's going to form aluminum oxide. So I have Al2O3, aluminum oxide. The very fact that aluminum allowed itself to bond with oxygen is a chemical property. Remember, a chemical property is just saying if something and how something will react with another compound. After the combination of aluminum oxide, that little film that's on the top of that is no longer aluminum, and it's no longer oxygen. It's a new thing called aluminum oxide with its own properties and with its own chemical reactivity properties, its own physical properties, its own luster, its own density, its own whatever. It's a brand new matter. Of course, not new to the world or new to the universe, but new to your data set. So, if there's any confusion on that, a chemical property is just something that will change if the chemical makeup changes. Well, I'm sorry, I worded that wrong because the physical property will change too. It's how or if something will change with another thing. So, examples of chemical properties would be, when we're talking about reactivity, we're going to talk about, let's get a couple down here. Flammability. Flammability. Well, what is fire? Fire requires oxygen. if I take a piece of wood and I add oxygen to it, nothing. Nothing, nothing, nothing. Doesn't matter. But if I take that wood and I add fire under the right amount of conditions, which is increased heat, then that wood starts to combine chemically with the oxygen. All the compounds that make up that wood, all the cellulose, all the plant life in there, all the carbon compounds, it combines with oxygen to form a whole bunch of thousands of different compounds, and changes phase and all these different things, and it goes away and smokes and leaves an ash. That smoke that's formed, that gas, and then the colloid that's formed from the smoke of those solids inside the gas, those are new compounds. It's no longer just oxygen, and it's no longer the particles that make up the wood. That's a chemical property, the fact that I was able to do that. So, another chemical property would be how toxic something is. Well, what do we mean by toxicity? Well, we're talking about how a compound will react with important compounds in our physiology, important compounds in our body. I mean, to a certain extent, when you think about alcohol, is kind of toxic, right? The chemical compounds of alcohol messes with our body, and it impairs certain functions of biochemical functions of our body, that it impairs us, that we are no longer able to operate at a efficient level. It also changes your ability to think on time, and lowers inhibitions. All those different things are due to alcohol. The combination of that chemical compound of alcohol. Okay, then that's a chemical property. How it will react with specific compounds in our body. Those are the chemical properties. Whether or not it's chemically stable at certain temperatures and pressures, or will it will want to react immediately. So, for instance, let's take some alkali metals. So, in a lot of chemistry classes, they get out silicone for the first time, and the silicone itself is a very, it's a very shiny metal. So I have some silicone here, okay, and then I'm going to take a knife, and I'm going to cut that out. And when I cut it, it's going to be really, really bright where the oxygen hasn't hit it. Now, that's because in a couple moments, the sodium. I've been saying silicone, but sodium. Let's take sodium. And sodium is a very bright, lustrous metal. And the moment it hits oxygen, it starts turning dark, so it's highly reactive to the oxygen. Whereas iron, if you take iron and you let it sit outside, it's going to take a long time for the oxygen to react to it. That is a chemical property. Now, if you take iron and you put it in water, nothing's going to happen. It's going to rust faster, but that's just it. Nothing else will happen. But if you take silicon and you put it in water, it's going to cause an explosion. It's going to immediately catch fire, and if there's enough of it, it's going to explode. That's a chemical property, its ability to react. So I hope that's cleared this up. If you have any questions, again, come and see me after class, or rewatch this video, or look for another video on YouTube that might have done a better job explaining this. Thank you, and you have a good night, or a good day.